All right, y'all. So let's begin this Molarity and Solutions practice test. The blank test will be in the description along with the answer key, starting with question 1. I have a 3.7 molar solution of potassium oxide. Answer the following questions. What is the solute? Well, that's just potassium oxide. The solute is a thing that is dissolved. Thing doing the dissolving is the solvent, which is usually water, especially if we just say a solution of potassium oxide. You can assume it's water. Now, to help us out later on, let's figure out the potassium oxide. Potassium is K plus as an ion, oxygen is 2 minus. Therefore, potassium oxide is K2O. So the charges will balance out. Furthermore, this means that for every one potassium oxide, I will have two potassium ions and one oxygen ion or oxide ion. So it's 1 to 2 or 1 to 1 ratio. All right. So see, I have 446 milliliters of the solution. How many moles do I have? So we're going to use molarity is equal to mole solute over liter solution. In this case, we are going to change it to moles. It's equal to molarity times liters. Now that does mean we'll have to convert 446 milliliters into liters, but that's not too bad. So 3.7 molar times 0.446 liters, the conversion just dividing by 1,000 or moving the decimal over 3 times. That will get us that our mole is equal to 1.7. In other words, we have 1.7 mole K2O. All right, assuming the same volume as C, how many moles of potassium do I have? Well, there's two ways we can do this. First way is recognizing that it's a 2-to-1 ratio. So we can just double it. So we can just say on our first thing, 1.7 mole times 2 is equal to 3.4 mole K plus. And that's an answer. The other way to do it is knowing that it's a 2-to-1 ratio, start by taking our 3.7 molar solution, multiplying that by 2 to get 7.4 molar concentration of K plus, and then taking that and multiplying it by 0.446, which will give you 3.3 moles potassium. The difference comes from the significant figures that get kept or lost along the way, so don't worry about it too much. I will accept both answers as correct. Assuming the same volume as C, how many moles of oxygen do I have? Regardless of which way you do it for this one, method 1 or method 2, it's still going to be the same. It's going to be the same as 1.7 mole K2O, which is going to be 1.7 mole O, 2 minus. Now, that's because it is a 1-to-1 ratio. All right, assuming the same volume, see how many grams of potassium oxide do I have? Well, to get grams, we're going to start with our moles, 1.7 mole K2O. We're going to use a little bit of conversions to use 1 mole is equal to 94.2 grams. That is using the molar mass, which is in grams per mole. Moles will cancel with moles, and I will get an answer of 160 grams K2O. Now, it's not exactly 160, but again, that's using significant figures to keep all those correct. How much will the final volume be if I dilute the solution to 3.0 moles or molar? Well, I know that I can use M1V1 equals M2V2 because this is a dilution problem. If I'm looking for our final volume, volume 2, I can just rearrange this to volume 2 is equal to M1V1 divided by M2. And I'll plug these values in. We have 3.7 molar times our original volume, and for this one, we don't need liters. We can keep it in milliliters, 446 milliliters, all divided by 3.0 molar. Now, when I do this, the units molar cancel out, so I am left with milliliters, meaning that my volume 2 will be in milliliters, and I get 550, once again accounting for sig figs. That would also be 0.55 liters if you're using liters. All right, H. I add 39 grams of potassium chloride to our original solution. The new volume of the solution is 0.45 liters. What is the molarity of each ion found in the solution? And we're looking at K, Cl, and L. Well, to figure out the molarity of each ion, we first need the moles of each ion, the mole of each ion. I'm going to write that over here. So our ions are K plus, Cl minus, and O2 minus. Now, I know from before I started with, let's see, either 3.3 or 3.4 moles. I'm going to use 3.3 moles, but you can use either. Oops, too far. So I started with 3.3 moles. Cl minus, we don't know the moles yet. We're going to have to calculate that. And O2 minus, looking from before, we have 1.7 moles. Oh, too far again. 1.7 moles. All right. So how do we find Cl minus? Well, if we look at potassium chloride, KCl, and we have 39 grams of it, we can convert that to moles. And that's going to be 1 mole on top and 74.6 grams on the bottom. That's using the molar mass, which will get me a value of 0.52 mole KCl. Now, KCl breaks into K plus and Cl minus, and that is also a 1-to-1 ratio, meaning 1 mole of KCl turns into 1 mole of K plus. Therefore, 0.52 moles turns into 0.52 mole of K plus, and 0.52 moles turns into 0.52 moles of Cl minus. So I can go ahead and add these in. So first, for potassium, I now have an additional 0.52 moles. For chlorine, I have a starting value of 0.52 moles. Now that I have the total moles for each of these, I can divide by our new volume, which is 0.45 liters, 0.45 liters, 0.45 liters, and 0.45 liters. And I will find, and now I'm going to just rewrite everything a little bit over to the side. Then for K plus, I have a molar value of 8.5 molar. For chlorine, I have 1.2 molar. And for oxygen, I have 3.8 molar. And those are my values. All righty. Number 2, I want to prepare a solution of calcium hydroxide, CaOH2. I'm trying to prepare 78.0 milliliters of the solution at a molarity of 1.3 molar. So I attempt the following procedure. I first gather 1.3 moles of calcium hydroxide. I put that in an Erlenmeyer flask. I use a graduated cylinder to measure out 78.8 milliliters of water. I pour the measured amount of water into the Erlenmeyer flask containing the calcium hydroxide, and I mix the solution until the solute has dissolved. List 2 errors. Well, first off, I know that 1.3 molar CaOH is not the same as 1.3 grams. Molarity must first be converted into moles, and moles must be converted to grams. So right at the top, A, we don't equate grams with molarity. Grams does not equal molarity. Please know. For number 2, usually when we add water to something or add something to water, the volume goes up. So we can't use 78.0 milliliters H2O. We shouldn't be doing it. So why are these incorrect, and provide math to support your answer? Well, for number one, to find out how much calcium hydroxide we actually need, we will say we will find the proper mass of CaOH, and we'll show that work right down here. We know that mole is equal to molarity times liters. In our case, it is 1.3 times 1.3 molar times 0.078 liters, which gives us a value of 0.10 mole CaOH2. From there, we'll convert that into grams by using the molar mass. 1 mole is equal to 74.1 grams. Mole will cancel, and we will find that we need a mass of 7.4 grams CaOH2. So number one is wrong because instead of 1.3 moles, we need instead of 1.3 grams, we need 7.4 grams. Number two, we actually kind of have to explain this. Whoops. For number two, we have to explain that you must add less water, as the solute also has volume. So some idea that shows us that we have to add less, and then we pour this into a grad cylinder and add water to 78.0 milliliters. Basically, what I'm saying is once we've mixed the solution with less water, we'll pour the whole thing into a grad cylinder and dilute that back up to 78.0. All right. Last question. You have 59.3 grams of magnesium chloride. I ask you to make a 1.5 liter solution of a 0.21 molar solution of magnesium chloride. How many grams will we have left over? Ooh, so we're asking about what's left over. So for this, we're going to find out how much we actually need. We'll use our mole is equal to molarity times liters, which is 0.21 molar times 1.5 liters to find that we need 0.315 mole MgCl2. Once we know that, we can take 0.315 mole, multiply it by the molar mass, which is about 95.3. If you got slightly different numbers because you have a different periodic table, that's all right, as long as we're in the vicinity. Mole cancels with mole, and we get a total mass of about 30.0 grams MgCl2. But that's how much we're using. We start with 59.3, so we have to then take 59.3 minus 30.0 grams, and we will get total 29.3 grams left over. And so our answer is 29.3, or something within that range. All right, hopefully this helps, and have a great day.